I'd also like to start with a disclaimer. I think when we talk about open data in the biomedical and the medical space, I think no one is debating the fact that we need to have access restriction due to personal privacy and review by ethics committees or institutional review boards. And I think Scott pointed out it was really the distinction between choosing who you share with or choosing not who you share with from a collaborative point of view. But I think that there is really no way around talking about data sharing in the translational space without mentioning the, I guess the word is interest-generating editorial in the New England Journal of Medicine last year, where people who were using the data generated by other clinical trials or other research projects was branded as, I think the word was data parasites. A lot of good came out of this, and one of the things that came out, I think, was a very healthy debate about sharing of clinical trial data that culminated in this SPRINT challenge, where data from a large cardiovascular study, the SPRINT trial, was made available to a large number of researchers worldwide in a competition, essentially, for how you could mine that data. But taking a step back from the biomedical domain, we know that open data has a very large value. So we can think about all the apps that we have in our phones on meteorology that relies on the data released every day from the American NOAA Meteorological Association. This is an example from another US government agency, which is the Landsat data set from the imaging satellites. And so this was, for many years, a restricted data set. It was licensed, and so it's been collected for a long time, since the 60s, and other agencies and companies could license the data set for use in their own internal processes. It was quite a large, important revenue for the Landsat annual license was about $6 million. So however you do calculate, that's a lot of money coming into an institution, and it actually takes a bit of thinking before you go open with that. But actually in 2009, they decided to have a free and open data policy. They would just give this data set away. And the reason was that they realized that most of those $6 million were coming in from other government agencies. So there was not any new money, it was just shoveling money around in the taxpayer system. But I think what is really interesting is that what happened is the exponential increase in use of that data set by other customers that would never have started to license the data. And today they've estimated this is about $1.7 billion market, the value of the Landsat images in downstream applications. So I think what it shows is that if you remove encumbrances on data access, a lot of people will be driven by curiosity and opportunity and start to do something interesting with it. And that can generate quite substantial economic value for society, not necessarily for the center that actually have the costs associated with the data. In science and life science, of course, we know that our data is intensively reused. So these are just two examples from my career. Scott mentioned I've been in AstraZeneca for many years as a molecular modeler in structure-based design. And the PDB archive was the first open data archive, founded in 1971. About 15 years later, sorry, there is a bit of an echo, so I'll try to move around. About 15 years later, Janet Thornton and others realized that there was enough data in the PDB that you could actually start to do meta-analysis. And they published these sort of seminal papers on protein structures that led up to the whole protein modeling field. An additional 5-6 years later, Hans-Joachim Böhm at the BASF in Ludwigshafen realized that you could actually use the data in PDB together with binding data on small molecules to generate sort of statistical scoring functions that describe how well an inhibitor would bind to a protein. And he built the first sort of structure-based design program, which he called LUDI, Let Us Design Inhibitors. And that was, of course, all based on open public data. But what I think is really interesting is that this now is a very, very active market. So a lot of companies are active in this space. They use the public open data to develop algorithms and to calibrate their algorithms and scoring functions, and actually the total value of this market is again over $1 billion. So I think for me what these two examples shows is that there is not only sort of innovation in the scientific and the curiosity sense of the word, but there is also quite a lot of innovation potential in the European Commission sense of the word, but that means ability of creating companies in the larger society. And so the business model then for this open access data is the same business models as we have for roads. You build a road and all the small companies travel on the road, and that's just part of society. So how is it in the medical domain? And I think this is a really interesting example of open data in the medical domain. It's the Humanitarian Data Exchange, the HDX, which is sort of a Wikipedia of humanitarian data. It was built by the UN and launched in 2014 at an open data conference in Berlin, just about the time as the Ebola crisis hit Africa. And so initially this was geared at two projects in Kenya and Colombia, but actually they realized very quickly that this was the platform they needed to manage all the public health data in Western Africa. And so during the Ebola crisis, this open data platform was fed by WHO and others. And I think what is interesting, in addition to the fact that it was incredibly helpful, I think, it was using quite sensitive data given the stigma that was associated in that society with being an Ebola survivor, where you run the large risk of being ostracized from the community, is that it had very detailed geographical knowledge on cases and fatalities and healthcare workers infected and the location of the treatment centers and sort of the status and the location of burial teams for the victims. So all actually quite sensitive personal data, but at the height of the crisis, you had to just do away with some of these concerns because this was being used for things like response plan coverage, but also planning food assistance. So of course, if you have Ebola, you're not tending to the rice bodies, and so you need the humanitarian aid. And so I think this is a really good example of a lot of different data streams coming together, and the fact that it's open and unencumbered make it possible to add a lot of layers of innovation on top. So Scott mentioned the reasons for data, why we're not sharing data, and that was a good plug. You didn't know this, but actually there was a systematic review of the barriers to data sharing in public health, published in BMC Public Health 2 years ago. And actually, what is interesting is that this is a meta-analysis of the scientific literature where people talk about barriers to data sharing. And if you look at the top reasons, well, the first one is that data wasn't collected, which is probably true but not very interesting. But then you have, as the top hitters, things like the lack of metadata and the lack of standards, the lack of resources to drive data sharing, and the protection of privacy. Whereas things like restrictive policies and lack of proportionality, i.e. getting something back for data sharing, wasn't quoted very frequently in these reports. And I think it's quite nice to be at an ETRIX conference and present this, because if we look back at the ETRIX project, it has actually systematically addressed, I think, these barriers. You have the standard starter pack, you have the work that we've done on the principles for data sharing and reuse, and ETRIX in itself have of course been addressing the resource need for data sharing by the systematic curation. So I think if you've been working in public health, you would be on the right track. How it is in translational, we don't know, I guess. And so I think the final point I'd like to make is that actually open data sharing really is about long-term asset management and doing that effectively and scalably. And I think we've seen over the last couple of days the increased cost of trying to keep things hidden in today's world. They're actually quite significant. So unless there are good reasons to keep things behind the lock, an open data policy will serve you well in a rather hostile internet environment. But I think fundamentally it is really about finding effective lifecycle management and sustainable approaches to share what is ultimately a public good, an investment by the public in science for the benefit of healthcare and society. So I started with a sprint challenge, and I'm sure you wondered how it went. At least those of you who didn't follow the webinars. These are the two of the winners, and I think what is interesting with this is that they were looking at the data. They came up with new approaches that wasn't part of the original study protocol to assess individual risk scores, and actually some of them went further and validated those risk scores in independent trials where they could see the same pattern. Now, of course, these are not regulatory quality tools or anything like that, but I think it's a good demonstration of the power of openly shared data. And I think the other thing which is really nice is that the winner was a small startup company in Israel. And so they had nothing to do, and they were not part of this community that were involved in the large sprint-funded trial. And so overall, they had about 143 submissions to this data challenge from 107 institutions in 26 countries. And I think that's my final point on open data. You can harness good ideas wherever they are in the world. So.